Hey guys, today's lesson is all about pedigrees. It's actually our last lesson of this chapter, so we will be having our quiz next. And honestly, this is a short lesson, but I am going to give you some practice pedigrees to do as well. Honestly, the only way to get good at pedigrees is to practice doing them. So I'll give you a kind of like a couple tips on how to read pedigrees, and then it's really just like practice, practice, practice. Okay, so let's get into it. Okay, so like I said, we're going to be going over pedigrees. We'll briefly talk about what the point of pedigrees are, but mostly we're going to be analyzing or reading pedigrees to figure out if we're dealing with sex-linked or autosomal traits, as well as to tell if the trait is dominant or recessive. So a pedigree is just the pattern of inheritance of human traits. Usually it's kind of like a family tree. So you'll start with like the grandparents, and then it'll split off into all of their children and then their children's children and that kind of thing. And the point of analyzing pedigrees is to tell if a trait is dominant or recessive, autosomal or sex-linked. These are some of the different pedigree symbols that you'll be using. So a square represents a male, a circle represents a female. If a square and a circle have a line between them, it means that they have, they're like married or are together or have children together. If you have a line coming down from that, like this kind of a shape, anything that's coming off of that line are the children, that sort of thing. Sometimes affected individuals are colored in. Usually it's in black. And sometimes heterozygous individuals are half colored in, though oftentimes we don't know if an individual is heterozygous or not, if it's a recessive trait. And then lastly, someone who is deceased will have a line canceling out their circle or square. You guys will get a handout or an electronic copy of the handout that shows all of these different pedigree symbols. That's my dad. If I forget to give it to you, please remind me. You are allowed to use that on your test and quiz. So don't think that you need to memorize these symbols, okay? Okay, so when we're looking at a pedigree, the easiest thing to tell is whether or not it is likely X-linked or not. So if it's affecting way more males than females, then we can assume that it is X-linked recessive. If every daughter of an affected man is affected, yet none of the sons are, then it's X-linked dominant. And if it's only affecting males and no females, then it's Y-linked. If it's affecting males and females roughly in the same amount, then it's autosomal or not sex-linked. And then the next thing that we look at is whether it's dominant or recessive. Dominant traits will often show up in every generation, whereas recessive traits will skip at least one generation. And I'll show you what that looks like as well. So let's do some practice questions here. So in this example here, you can see that we have 2 males that are affected and 3 females that are affected. That's roughly half and half. So because of that, we would assume that it's autosomal, not sex-linked. And then as far as whether or not it is dominant or recessive, here you can see that it's not skipping any generations. So at the top here, it's in the grandparents, it's in the parents, it's in their children. So every generation is experiencing this. So therefore, it must be a dominant trait. If we look at the next example here, there's a couple things that tell us that this is definitely a recessive trait. And I'll get to that in a moment. But first, let's see if it's sex-linked or not. So we have, once again, 2 males and 3 females that have this trait. So again, roughly half and half. It's okay if it's not exactly half and half. As long as it is roughly half and half, then we're going to say that that is likely autosomal. Now, these are the things that show us that we have a recessive trait. This section right here, as well as this section right here, and this section right here. I could use any of those sections that I've just highlighted as proof that this is a recessive trait. And the reason that all of these work is because the parents do not have the trait and some of their children do. The parents do not have the trait, their child does. Okay, actually this top one doesn't work because they just married someone with the trait. So sorry, ignore that one. But yeah, either of these bottom two work because the parents are both totally normal, and yet some of their children are having the trait. That's what we mean by skipping generations. Essentially what we're talking about is parents who don't have the trait and yet their children do. Yeah, because of that, this is definitely a recessive trait. That's kind of the big hint that you'll be looking for to tell if something's recessive. Okay, how do I get rid of that? Okay, that is, I believe, it. Yep. So like I said, I will give you guys some practice pedigrees to work on and let me know if you have any questions.